Hello, and welcome to the series on the multiphysics analysis of a car headlamp in SimCenter 3D. In the previous videos, we saw how SimCenter 3D provides advanced geometry preparation, meshing, and mesh editing tools that allow you to manage the multiphysics digital twin in a robust and efficient manner. We also saw SimCenter 3D also provides a rich set of simulation objects, loads, and constraints from the thermal flow and structural solvers that simplifies and streamlines the creation of a multiphysics model. Finally, we saw how SimCenter 3D offers a rich set of powerful post-processing tools that helps you visualize the results in informative and instructive ways. From the last video in particular, we analyzed our results from full thermal flow and structural multiphysics solution using features like deformation animation and overlaid plot, which helped us to visualize the results in a comprehensive way. In this video, we will look at how to incorporate more complex physics such as solar heating, humidity, and condensation and evaporation.
SimCenter 3D Thermal includes sophisticated treatment of incoming solar radiation. For this video, I'm going to add the solar heating effect on the external faces of bezel and lens, which will be the major two regions exposed to sun. To add the solar heating effect into the simulation, simply click Solar Heating. The solar heat flux is calculated based on the position of the sun in the sky, the orientation of the model, as well as the shadowing elements. Also, the user can model the full day or partial day by assigning the start and end time depending on user's interest. Moreover, in SimCenter 3D, atmospheric attenuation and scattering is modeled with greater precision along with the ground reflection. It is therefore possible to model the effect of a solar heating on the lighting system under different weather and climate conditions by simply changing the parameters in the solar heating dialog box. Changes to the humidity levels in the lighting system are modeled by simply initializing the air internal fluid with a specified amount of humidity. The flow solver then accounts for the humidity transport and evolution over the course of the simulation. At high humidity levels, it is possible that the water in the air will condense onto colder surfaces. Condensation analysis is activated via a simple toggle in the solution settings. The SimCenter 3D thermal and flow solvers will then account for the condensation and evaporation of water on surfaces inside the lighting system.
In this video, we saw how SimCenter 3D multiphysics environment allows users to easily build on existing models and include advanced physics into their model. Complex physics like solar heating, humidity, and even condensation and evaporation can be incorporated into the simulation with just a few clicks. This is the end of the headlamp demo series. Thank you very much for watching.